Hey YouTube, welcome back. So apparently watching satellite TV with an SDR is a thing now. Snarky jokes aside, this application's actually been around for a while now. You can see here RTL SDR blog has reported on it back in 2019, but essentially what this application is going to allow us to do is if we use an SDR, we can actually demodulate a DVB-S2 satellite signal in Windows. That's just insane. And I managed to get it working last night with some help from some people. But before we get into this, we're going to have to do some boring theory. I know you guys hate this section, but you can just fast forward to where I actually get into the meat and potatoes of this tutorial. But anyway, so this is a KU band universal LMB, right? And we can see here that the KU band for direct to home satellite TV exists between 10.7 gigahertz and 12.75 gigahertz, right? So at 11.7 megahertz, there's a point where the LMB will change its local oscillator frequency, right? So when we've got 10.7 gigahertz to 11.7 gigahertz, the LMB is in a mode called low side mixing. Okay, and if we just follow this little flow chart down here, so the satellite receiver will be sending no 22 kilohertz tone, okay? And then that means the LMB is hearing frequencies from space through the satellite dish and the LMB at 10.7 gigahertz to 11.7 gigahertz, right? So because microwave signals do not propagate very well, the LMB will down convert that signal to L band. L band is a lot better at getting sent through wires and propagating. So the LMB performs the down conversion and converts the signal down to L band, which is at 950 to about 1.9 gigahertz. So that's what the DVB-S tuner is hearing as it comes through the coaxial cable into the receiver. And when we're viewing the KU band spectrum with SDR Sharp or your favorite SDR front end RF software, we'll be using a shift value of that number there, which I think is 9,750,000,000 hertz, okay? And then at 11.7 gigahertz, so when the tuner wants to hear 11.7 gigahertz and beyond, all the way up to 12.7, the receiver will start sending a 22 kilohertz tone, okay? And then that puts the LMB in high side mixing mode. And if we just follow the flow chart again here, the LMB is hearing from space 11.7 to 12.7 gigahertz, right? The local oscillator inside the LMB down converts that to L band, 1.1 gigahertz to about 2.1 gigahertz. And then the DVB-S tuner is hearing that signal. And then in SDR Sharp, if we want to view the KU band spectrum in our favorite SDR software, we use a shift value in SDR Sharp of 10.6 billion hertz, okay? So, and don't forget, satellite signals can be polarized in vertical and horizontal, okay? So we can have low side horizontal and vertical, and we can have high side horizontal and vertical, okay? And yeah, these notes here just above my head, the DVB-S tuner sends 18 volts to the LMB, that triggers horizontal mode. And then when the DVB-S tuner is sending 13 volts to the LMB via the coaxial cable, that switches on vertical polarization, okay? Okay, that's the boring theory stuff out of the way. What are you going to need to watch satellite TV with an SDR in Windows? So you're going to need something called a splitter, okay? And this thing here will basically split the signal into two. And the reason we do that is we use a DVB-S tuner to power the LMB and trigger the 22 kilohertz and do all that fun technical stuff that I explained in this diagram here. Next thing you're going to need is a DC block. Now, I measured the voltage in this port of my splitter and I only measured 0.089 volts or something like that. So I don't know, I'm not an electrical engineer, guys. I'll let you make that decision whether you want to use a DC block. Probably to be on the safe side, to avoid frying your SDR, I would obtain a DC block, okay? It's not going to hurt having a DC block in line to prevent voltage coming back through the splitter and into your SDR's RF front end, because that's bad. And you will break your very expensive radio hardware if you do that. So, and yeah, the software that I alluded to previously, you can download that at this link. All the links will be in the description and the pinned comment like normal, so you guys can have a look at that. And okay, now's the fun stuff. Let's talk hardware. Everybody loves hardware. So yeah, this is my Frankenstein bird's nest of a setup here, guys. I've got my 5930, because I don't care if this thing gets fried if I make a mistake. I really do not like this thing. It's garbage. I've got my very expensive HackRF one there. I care about this SDR the least because they suck, but it's still good enough for transmit-only projects. I've just got some LCU 195 here that goes to my DC blocker. So that's going to prevent voltage coming back through these lines, through the splitter and into the SDR, okay? I've got a F-type male to SMA female adapter. That's there, it's hard to see. Obviously, yeah, we've got our splitter. And then this white coaxial cable, that's just going to my 5930 DVB-S tuner. And then, yeah, then I've just got RG6 going out to the satellite dish, okay? So this is how you configure your hardware if you want to emulate this setup, guys, okay? There's other ways to do this. This is just how I do it, okay? There is other ways, just letting you know that. All right, cool. Let's get to the fun practical stuff now. Sorry about rambling there, but yeah, this stuff is, like, blows my mind, okay? I need to explain this stuff so you know what's going on. So, okay. This tutorial is going to assume that you have a working satellite setup already, okay? We're not going to cover that. I've done that hundreds of times before in other videos, but welcome to EBS Pro. And what we're going to do now is we're just going to show what DVB-S2 signals look like in SDR software, okay? So you can just browse around and have a look. So I'm going to go to the RF scan tab, okay? So remember in this diagram here, guys, we're using the DVB-S tuner to trigger these various modes, okay? All right, like I alluded to previously in the video. So I'm going to view, what I want to do is I want to view the Ku-Band RF spectrum from 10700 to 12750, and I'm going to look at horizontal mode, okay? This is just a demonstration. So I'm going to change the frequency start to 11700. I'm going to change frequency stop to 12750. And then I'm going to change the polarity just to horizontal. Now I'm going to start my device and I'm going to press start. And let's see, we should have some signals showing up somewhere, I reckon. So right now, the DVB-S tuner has triggered horizontal polarization, and it's sending the 22 kilohertz tone to the LMB to tell it to switch to high mode mixing. And then, yeah, all these spikes from the noise floor shows us we've got a signal. Now, how can we view that in SDR Sharp? I'll show you. So, I'm going to go to SDR Sharp. I've got my HackRF here. I'm going to go to 1.925. This is just for the demonstration, guys. You don't have to do this, but I'm just going to browse to this. I'm going to press start. And we should see we've got some signal there, guys. I'll just, so yeah, welcome to Ku-Band. So this is actually viewing real DVB-S2 tuners. Transponders. Cool. Now you can see here, like, Rob, why is it showing an L-band frequency here? Well, we need to use the shift function here. So I'm going to copy and paste this value here, 10.6 billion hertz. So I'm going to tick shift, then I'm going to paste that frequency there, and then all of a sudden you can see it's doing the frequency conversion behind the scenes, and now we can actually be like, oh cool, now I know where I'm looking now. So yeah, that's pretty cool. All right, let's do vertical, and then let's do the low side mixing now, just for demonstration purposes. So I'm going to stop the SDR. I'm just going to stop my tuner for a second. I'm going to go to the RF scan tab again. I'm going to put 10700. to 11.699. Whoops, sorry. Whoa, what's going on here? Sorry, can't use Control A. 11.699. And I'm going to change my polarization to vertical. And then I'm going to press start. And yeah, you can see here now that the LMB is triggered into low side mixing mode now, and it's not sending a 22 kilohertz tone, telling the LMB to switch to the lower local oscillator. So the signal we're going to be actually watching is one of these spikes here. But first, let's turn, so I'll just untick shift, and then we'll go to 1861. Now this is a single channel per carrier feed channel. Okay, so with this AMSAT DVB-S demodulator is very limited, right? Like you'd be lucky to receive any more than maybe 5 megahertz wide DVB-S signals. You're just limited to like USB bandwidth, the processing overhead load on your computer, that kind of stuff. So I'm going to hit start on my SDR, and then signal, this is the feed channel here. This is single channel per carrier mode, right? So DVB-S signals they can just be single channel per carrier. So you just got one TV channel on one carrier, or it can be one carrier and then have like 40 channels in it. You just don't know, okay? So we can see here we've got our L-band frequency here. So let's configure the shift function to actually do the frequency conversion in the background there. And you can see here, 11.611 is roughly the channel we're going to be decoding. So yeah, that's how you do that. I'll just open that up so you can see. Oh yeah, this is just my HackRF parameters here too, if you want to like copy that. So anyway, I've got 20 megasamples per second, so I can see about like maybe 18 megahertz of the spectrum. So, but yeah, DVB-S2 signals are very wide, right? And typically they will exceed the bandwidth of an SDR. So you're going to need something a bit better than a RTL SDR for this guy. So I'm just using my HackRF because it can do 20 megasamples per second bandwidth. So, all right, cool. All right. We don't need the SDR anymore. I just thought I'd show you that. Actually, I'll just show you something just to prove that it's not the DVB-S tuner receiving this signal, and it is in fact the RTL SDR. If I go like this, stop device, the signals disappear. And then if I go restart device, you can see the signals come back. So that's just going to show you that it's not the DVB-S tuner doing this, it's actually the HackRF, all right? All right, cool, we don't need SDR Sharp anymore. I'm going to minimize that, and I'm going to get my file manager up here. So yeah, let's move to the DVB-S Demod GUI portion now. So I'm going to just extract the application on my desktop, right? Again, you guys can go and get it from this link here. All right, cool. So let's browse into the directory here. And I'm going to close SDR Sharp in case there is a conflict with the two apps trying to use the SDR. Okay, I'm just going to double click DVB-S GUI. This is just the log window, guys. I'm just going to move this down here for a second. Cool. Righto. Welcome to DVBS-S2 Demod GUI. Okay. Very cool little application we got here. All right. So, first things first, we need to open the SDR. So I'm going to hit open device. Okay. And then, yeah, things start happening, which is a good sign. We get some log stuff coming up in the log window. I'm just going to turn up my BB gain slightly. So maybe just about there. So you don't need too much gain, guys, because the LNB is actually sending quite a strong signal indoors. So you really do not need a lot of gain. And if you exceed the input voltage of your SDR's RF input, you're going to have a bad time. So don't do that. Just keep the gain levels very low for me, please, guys. Okay, I'm going to change the VFO now to 1861. Okay, so this is the waterfall, guys. Just going to turn the BB gain up a little bit more. Okay, I'm going to change the symbol rate now, because I've got the, I know the, this particular transponder that I am targeting is, symbol rate is 3580. I'm going to press OK on that. Alright, for some reason, I don't know, there's this freaky thing going on with the bandwidth. There's 2 8 megasamples per second, so when I choose the second one, it typically fixes everything. I don't know what's going on with that. Alright, so now we use the right click button on our mouse to drag the VFO around, okay? This thing here is called your VFO, okay? And then I'm just going to ensure that the signal is encompassed, right? And then this thing here is called the IQ plot, right? And when you've got a circle like that, that's good, okay? This is like the modulation constellation, right? These are all the various symbols, okay? I'm not an RF engineer. I wish I knew more about it. Okay, so when you've got your VFO encompassing the signal, guys, oh yeah, just make sure you got DVBS2 ticked here as well. And then once you've got this circle going on here, guys, tick carrier recovery enabled. There we go, look at that. So we're actually locked, and we've got sync confidence 32. I've never got it to go higher than 32. I don't know what's going on with that. We've got an excellent signal here, guys. We've got nearly 16 dB, so this is a 1.2 meter dish connected to that. And you see all these symbols have now arranged them into like nice little dots now. Okay, oh, I just lost sync there for a second, but never mind, it's all good. And yeah, it's even got the name of the single channel per carrier channel there. So this is ABC Sydney. This is a feed channel, okay? All right, everything's going to plan so far. That's excellent. So, what are we doing now? So, how do we watch television with this now? It boggles my mind that this is possible, but anyway, okay. We go to VLC Media Player, guys, okay? You can see here, recording/network section of the application. So typically it's like that. Nothing is selected. So UDP doesn't work for me. It never has on my network. I don't know what's going on. So I'm going to select TCP. I'm going to go to Media, Network Stream. And then in the past, I've already tested this, so I've already got it in there. But if you guys want to copy and paste that, I'll leave it in the description in the pinned comment so you can copy and paste. And then guess what? I'm going to go play. Now there is audio with this, but because this is a remote PC, we can't hear audio, unfortunately. So look at that, man. We're watching television with a HackRF DVB-S2 from a satellite. What? So there we have it, guys. That is DVB-S2 decoding a feed channel on a satellite here in Australia. Isn't that just mental? What a cool application, man. But yeah, anyway, thanks for watching. I hope you guys found that enjoyable. I know it's a long video, but you know, these technical topics take time. So yeah, thanks for watching, and I'll see you next time. Bye.